Hello, my name is Robert Henderson. Welcome to my studio. Uh, I'm a multimedia artist and musician based out of Tucson, Arizona, and I'm really pleased to have the opportunity today to talk to you a little bit about my creative process in general and my creative process as I went about creating the piece that I'm presenting for the Hourland residency. So I mentioned a moment ago that I do multimedia art, and that's art that um, involves, it's quite broad, but it involves sound, video, visual elements, technology, audience interaction. And in my particular case, I'm very interested in sound and visual presentation of sound. The work that I'm presenting for Hourland and that I've done in the past has heavily used uh, visual programming languages for manipulating sound, like Pure Data, Plug Data, or MaxMSP. Um, and so I wanted to kind of do a quick introduction to that because I think the rest of my work won't make much sense. So I'll do a quick introduction to sort of this programming paradigm, and then I can talk more detail about how I use it in my work and how I'm using it in particular for the work I'm presenting for Hourland. So I'm here on the screen. I have a window, I'm currently showing you Plug Data, which is, as I mentioned, it's a visual programming language for manipulating sound. And so let's do that. Let's do some sound manipulation. So let's suppose I wanted to create, I can zoom in so it's a little bigger. Here I'm gonna create a node. We're gonna do a little programming. I'm gonna say, give me some noise. So you can see here it's uniformly distributed white noise. And I'm gonna multiply that signal by a small number so that it's not super loud. And actually, if I hover here over this, you can see a little oscilloscope. You can see the sound wave. And then I can send this sound wave out to the audio output, and you should hear that. Yeah, let's make it even quieter. Yeah, so we have just noise, right? And now we can do various cool things with this noise. Like for instance, let me introduce a metronome that beats every 200 milliseconds. And then every time the metronome beats, it's going to give me a random number between 0 and 100. And then let's divide that number by 100 so that we get a number that's between 0 and 1. And then let's pipe it into this thing. So that will actually change the volume. If this was modulating the volume, now we're going to pick numbers and it will modulate the volume. You need to start the metronome with this little button here. Ooh, exciting. Exciting. So I have a little thing here. It's kind of cool. Let's make it even nicer. I'll just keep it really quiet. Let's add a little filter here, bandpass filter, and let's filter at 1,000 hertz. Oops, wrong kind of box. We'll filter that at 1,000 hertz. Let's add a little slider here. Oop, I put that in the wrong spot. We'll filter this at 1,000 hertz. We'll have a slider here that will go up to 500. And the output of this will then go into our player. And we'll filter that noise through this little filter here. And hopefully let's get something that sounds cool. That's kind of nice. Yeah. So I'm kind of filtering this sound at, filtering that white noise we heard before at 1,000 hertz. And this slider over here is saying how wide that filter should be, essentially. Okay, that's great. We have a little sound here. And I could change this. What if you made it 2,500? Yeah. Yeah, so what I'm doing here is I'm generating audio, right? I am programming with this sort of signal processing diagram, and I'm creating a recipe for generating sounds. Now, I like to think of this as kind of like a score, right? You might read a musical score, and it's an instruction for how to produce certain sounds in certain orders. The same thing is happening here. I'm saying produce white noise, produce random noise, and then multiply that signal by a value, or multiply that signal by a certain value every 200 milliseconds in a random way. Pass that sound through a filter at 2500 hertz, etc. So I really think of this as being like a score. Now, one of the cool things about these scores is that this is a visual programming language, and so what I can do is I can actually arrange them on the screen. Look, I can move them around, and I don't know, that's kind of looking cool. I didn't prepare for this part, but what am I going to do with it? I don't know. It kind of looks like a little cow or something with it, like a horn. There we go, that looks kind of nice. So I have this little cow creature that I've drawn on the screen with my score. It's continuing to produce sound. And really, this is sort of the core methodology I've been playing with in the work I'm presenting for Our Land, but also in previous work that I've done. Okay, so we can delete this. So my methodology is sort of creating compositions, creating these sort of scores that are programmed, and then drawing with them. Now for Our Land, I'm returning to some work that I did recently with a colleague, the poet Johanna Skibsrud. We did an installation at this area in Arizona called Whitewater Draw that is the home to migrating sandhill cranes. These cranes have one of the longest migrations of any species on the planet. They come down to Arizona. They go various places, but there's a large population, 20,000 cranes or so, that gather in one area in Arizona for the winter. And then after the winter's over and it's more hospitable in the Arctic, they fly back to the Arctic where they have nesting grounds. So some of them travel, it's documented travel as far as Siberia. So they go from Tucson, Arizona to Siberia over the course of a year. So it's an incredible migration. And it's a beautiful gathering of animals there in Whitewater Draw. And I'm sort of interested in this theme in particular, here in Arizona, we're a border state, close to the Arizona-Mexico border, and we're the site of a lot of, it's a contested space for questions of immigration and migration, and we have cranes migrating here, we have people migrating here, and there's all these questions about who belongs, whose presence is supported, and whose presence is excluded. The cranes themselves actually now have to be supported. The ephemeral, due to drought and increasing temperatures, the cranes have to have groundwater. The ephemeral sources of water that they need are no longer consistently accessible, and so groundwater is actually pumped into marshlands to support their presence. So I'm sort of thinking about these issues of sort of place and migration in the environment for Our Land. For this previous work that I mentioned down in Whitewater Draw, I've recorded field recordings of these cranes. I like to play you some field recordings a little bit. So this is what the cranes sound like. Pretty beautiful, I think. So I made that recording, and I was thinking about the sound of these cranes and sort of the concept of cranes, the cultural concept of cranes, and what came to mind is the idea of the paper crane, which is universal symbol of peace, and in particular, I started to think about the idea of folding paper into cranes, right? So transforming sort of one object into another through deformation, through folding, right? And I was thinking about analogs for that and the work that I do in the domain of sound. And you can think of certain kinds of synthesis, like we just synthesized that sound on the screen a moment ago. We could think of that as a kind of folding of the sound wave. So that filter that I put on the white noise is taking the sound that is outside the parameters of that filter and squishing it down. It's like smushing those frequencies down. So just like you might fold a crane, we can imagine generating a sound through certain types of synthesis. In this case, subtractive synthesis. We can think of it as like a kind of folding of the sound wave or deforming the sound wave into a new object or a new sound. And I wanted to play with that idea for the project that I'm presenting here. So what I did was I took individual crane calls. So here's an example of one crane call. That little call. And if we look at that call, we can see here, I can zoom in a little bit. I believe, yeah, this is that call we're just hearing. Yeah, so this is the visual representation of it. And here on these bands, it's dark where there is more energy. On the y-axis here, it's frequency, so frequency in hertz, and the x-axis is time. And you can see, for instance, like in this little band here, there's, a lot of energy here and here and here and here and here and here, sort of repeating pattern at various frequencies. So maybe this is 700 hertz and that's 1100 hertz, etc. I went through and for 9 of these calls, extracted that data, like where is the energy in the frequency spectrum, and I plotted it like here. So let's find one with more data so it looks more impressive. Yeah, so here's crane call number 3, and there's energy at 800, 1700, 2500, 3500 hertz. This is how wide those bands are. So I extracted that information, and then I was able to sonically sort of profile these crane calls. Okay, so I mentioned before I have this idea of playing with this idea of doing origami, right? Folding a paper into a crane, a piece of paper into a crane. So for this project, I was playing with the idea of folding paper sounds into crane sounds. So what I did was I recorded paper sound. So here's some paper sound for you. Yeah, so those are my paper sounds. And I then combined them in the following way. So I built a large number, actually 9, of these networks. So you saw on the previous page we did a tiny little one. Here we've gotten crazy with it. And let me zoom in on that first crane call 1. These numbers here, the frequency, these 5900, 5000, these are the frequencies at which we find lots of energy, right? Lots of sound in the crane calls. So I took that data that I extracted from the calls, I programmed it into this network, and what this network is doing is, you see it says open paper sound.wave. I'm opening that paper sound, I'm processing it in various ways. In particular, I'm filtering out sounds or frequencies that don't correspond to frequencies that are active in the crane's call. And that allows me to generate a fake crane call, a synthesized crane call. So let me show an example of that. So here is the original crane call, and then here's my synthesized version. Not perfect, but a paper crane doesn't look exactly like a real crane. So I think I've done something here. So that's conceptually what I've been doing. I've been taking these paper sounds and turning them into crane calls through subtractive synthesis. That's sort of stage 1. I mentioned previously that once I have this visual programming language, look, I can move these guys around and draw with them. And so I want to show that here, just one example. I then took those networks and I drew paper cranes with them. So we kind of have a kind of double origami. We have the sonic origami, and we also have sort of the visual representation of paper cranes. That's not it. I've colored them, and so I want to give you kind of maybe leave with this. So what I have here is I have 9 different cranes. I've rotated them, sort of what I'm calling tessellating them. I've tessellated them, an interesting visual impact. Eventually I might want to fold these into origami cranes, like actual paper cranes, and so I wanted them in 4 like this because you want a square piece of paper to fold origami. But yeah, these are the cranes that I made. And I'm going to play you the audio, so you're going to hear the 9 actual cranes, and then you're going to hear my 9 synthetic cranes that are generated by these networks you see here on this video. Yeah, so those are the cranes, and those are the synthetic cranes. That's my process. So my process has been sort of generating through synthesizing these synthetic crane calls, and then producing a digital representation of these paper cranes that have been incorporated in the final piece, which you'll see at the exposition. Yeah, so I can leave you with that. I can say that what I've taken away from this work, and what I hope you take away from it, is an appreciation for careful listening. I spent many hours listening to these crane calls and trying to sort of dial in the parameters perfectly to try to replicate them. And I think spending a long time with a sound can make you love that sound and give you a greater appreciation for the animal or that produces that sound, or instrument that produces that sound. And it's deepened my appreciation for the sandhill crane. And if you ever come to Arizona in the winter months, I highly recommend you try to see them and hear them and listen carefully. Thank you.